right, let's do this. All right, so today we're talking about the unit circle, pi over 2 and pi over 4. So, example 1. The unit circle comes from special right triangles. And you guys learned special right triangles back in geometry. And you mentioned them yesterday, though I think inadvertently. So what we have here is we're going to start with an isosceles right triangle. What does isosceles mean? Two congruent sides. A right triangle, so it's got a right angle. So I'm going to go ahead and just do that. So there's my right angle, and these are two congruent sides. So there is my isosceles right triangle. These have a side length of 1, so each one of these is 1 unit in length. What I would like to do is figure out the third side. How can I figure out the third side? Yeah. A squared plus B squared equals the hypotenuse squared. So, yeah, 1 plus 1 is 2. And then you take the square. This is really, really complicated math here. Okay, so let me take a square root, and we get that the hypotenuse has a length of radical 2. Yes, so this is what you guys mentioned yesterday about Pythagorean triples. I heard 1, 1, radical 2. This is where it came from. Now, not only are the side lengths 1, 1, radical 2, but if the side lengths are congruent, what do you know about the base angles? They're also congruent. So that was a whole theorem that if the two sides are congruent, then the base angles are also congruent, which means, how big are they?
They're both 60 degrees. No. Wait.
45, 45, 45, 90. So this triangle is a 45, 45, 90 triangle, and its side lengths are always 1, 1, radical 2. Always. Now, what we can do with this triangle then is we can say, hey, I want to make it bigger. And so I could multiply every single side if I wanted to say, I'm going to make this triangle 5 times bigger. Well, then this becomes 1 times 5 is 5, and this becomes 5, and the hypotenuse will be 5 radical 2. And it's still a 45, 45, 90 triangle, right? Okay. So it doesn't matter how small or how big it is. Okay, so I can multiply by 5. If I can multiply by 5, do you think that I could divide by 5? I sure could. I can multiply by anything I want to. That's a scalar multiple. Scaling it up or scaling it down. Okay? Now, no matter what triangle I'm looking at, what is the sine ratio according to the 45-degree angle? Opposite over hypotenuse. So opposite would be 5 over 5 radical 2. And those 5s reduce to be 1 over radical 2, which then you would rationalize radical 2 over 2 when you rationalize it. Do we get the same thing here?
Yeah.
Opposite over hypotenuse gets us right to 1 over radical 2. Okay. So aren't they all going to boil down to 1 over radical 2 then, ultimately? Yeah. No matter how big I multiply or divide. Okay. Well, that is the crux of the unit circle. Okay? What is the cosine ratio of the 45-degree angle? Adjacent over hypotenuse, which would be 5 over 5 radical 2. Oh, hey, wait a minute. That's the same, isn't it? 1 that's handy. Those are the same. All right, so we get 1 over radical 2, which then we would rationalize. So again, we get radical 2 over 2. Okay, that's great and all. Ooh, what I do here? What's pi over 4?
It's not when it's divided. So it'd be 180.
Ah, good thinking. Ladies and gentlemen, where is pi? 180 over 4 is 45 degrees. Okay. So pi over 4 is equivalent to 45 degrees. Lots of 4s going on there, right? Dividing by 4, 45. Hey, that's neat. All right. So what is the tangent ratio according to our also known as pi over 4 angle measure? Opposite over adjacent, 5 over 5, which is 1. And again, same thing here. Opposite over adjacent would be the same. Okay. All right. So having these friendly angles, and that's what they're called, friendly angles, so are part of our unit circle. So here we go. It's a ladybug. So you might want your circle because you want to make it big enough. So go ahead and get out your little circle and trace. Give yourself some room. Give yourself some space.
No, is this 16?
So this is the unit circle, where we're talking about pi over 4. Yeah, so you want to go ahead and split your unit circle a horizontal, the diameter, which represents our x-axis. So what I'm doing here is I have a circle, and it's a unit circle that's centered on the origin of the x and y coordinate plane, okay? So that's your call. Don't have to. It's a unit circle. Now my unit looks to be about 1 foot, perhaps. Your unit maybe is 1 thumb.
I don't get it.
I do not get it.
It's 1 unit. Okay. There's this whole episode of Curious George where they measure things based on the unit of George. How many Georges tall is it? It's so funny.
I've literally seen that.
Yeah, it's great. Anyway, what I'm getting at here is this is 1 unit. I don't know how big or small it is, but it's 1 thing. Okay? So your unit might be a little bit smaller, but it's just one of them, whatever that unit happens to be. Whether it's 1 foot or 1 centimeter or 1 yard or 1 mile, it's 1. Okay. Now, if my radius here, you guys really need to listen. If my radius is here, is 1 unit. Right now, I have a ladybug, and she is on an ordered pair. She's right there on the ordered pair. This is the origin.
So it'd be 0, 1, 0, 1. 0, 1. No, she's not the origin.
The origin is here.
The origin is 0, so she's 1, 0.
1, 0.
1, 0. Okay, yes, good job. Okay, so let me tell you about my ladybug. I'm training my ladybug. She wants to join the circus. She's very ambitious. Okay, and so she's learning right now how to walk in a circle. And so she requires some information. And so I have to tell her, first of all, how far she needs to travel. So T represents her traveling distance. Okay, and then she gets her reward when she lands on her point, P, as in an ordered pair, XY. There's some ordered pair that she lands on. So we want to know what point does she land on if she travels a certain distance. Well, to get going, right now, she's traveled a distance of 0. All right, so she travels 0 feet. What point is she at? 1, 0. Good, good. Okay. So she's mastered standing still.
Oh, yes.
Okay. But now she needs to go all the way around the circle. All the way around the rim of the circle is a measure of what? Circumference. There you go. All right. E-R-E-N-C-E. Okay, circumference. What is circumference?
2 pi.
2 pi r. 2 pi r, and our radius is 1 unit. And so the distance she's actually going to travel is actually 2 pi feet to get all the way around. So if she walks all the way around the circle, she would have traveled 2 pi feet. And again, she's landing at 1, 0, yeah? All right, good. You're with me, right? Okay, good. Okay, so now, though, she can go in this direction, which we're calling the positive direction. But she also can learn to turn around and go the other way. So she would maybe travel negative 2 pi feet. Does that make sense to you?
Yeah.
Traveling in the other direction. Is that okay? Can we do that?
Yes.
Yeah? Okay. All right. Very, very good. Okay, great. Now, my ladybug has mastered traveling in the positive direction and traveling 2 pi in the negative direction. And she's always landing at the point 1, 0 and getting her nice little reward. So that's awesome. Now, I need her to land right here.
It's pi.
Pi feet. So if she travels pi feet in this case, then what ordered pair is she landing at?
Negative 1, 0.
Negative 1. Very good. Negative 1, 0. Very good. Excellent. Okay, excellent. So not only can she go positive pi feet to get there, what else could she do? Oh, negative pi feet would also get us there as well. Excellent. Very, very good. Okay. Now, I want her to go to here. How far does she travel to get to this point? Half of a pi, or pi over 2. Excellent, ladies and gentlemen. And if she travels pi over 2 feet, what ordered pair does she stop at?
0, 1. 0, 1.
0, 1. 0, 1. Very good. 0, 1. 0 in the x direction, up 1. Okay. All right. So excellent. So wait a minute. I have a question. She can go pi over 2 to get there. What if she's going in the negative direction?
Negative pi over 2.
Wait a minute.
3 pi over 2.
Negative 3 pi's over 2. Negative pi over 2 takes me this far. Negative 2 pi over 2 up here would be negative 3 pi's over 2.
Yeah.
Now, so technically, could she keep going around the circle, traveling further?
Yeah.
Yes.
Okay, so she could go negative pi over 2, negative 2 pi over 2, negative 3 pi over 2, negative 4, negative 5, negative 6,
7.
negative 7 pi's over 2 would also work. So negative 7 pi. Okay, so are you getting the idea now that we can travel lots of distances here? Okay, that's fantastic because now, let's see. I guess I need to do one more here. We want to go to this point in the positive direction. How far does she travel? 3 pi's over 2, 1 pi over 2, 2 pi over 2, 3 pi over 2. And that's going to land her at the point
0, negative 1.
0, negative 1. Very good. Okay, excellent. And she could also go negative pi over 2 and get that same point as well. She's getting really, really fat now, so I'm going to stop talking about my ladybug for a little while. She needs a break. Okay. Ladies and gentlemen, I want to know what happens when I land here. How far did I travel to land at this point?
That's supposed to be the midway point.
It is. Pi divided by 4. So you can imagine here's pi. And if we divide it into 1 section, 2 sections, 3 sections, 4 sections, this is pi divided into 1, 2, 3, 4 parts. So this is 1 pi over 4. And if this is 1 pi over 4, what's this?
2 pi over 4.
2 pi's over 4. Hey, and it reduces, right? And then what's this? 3 pi over 4. Now, whatever I do to the top, I'm going to do to the bottom. So we're going to split that up. So this is 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, which is handy. That reduces, right? And this becomes 5 pi over 4. This is 6 pi over 4.
7 pi over 4.
7 pi's over 4. Now, ladies and gentlemen, let's just refresh our brains for a second. Pi over 4 is how many degrees?
That's 45.
45.
45. Lots of 4s, right?
Yeah.
Okay. Okay. So now, here's my problem. If we have traveled pi over 4 feet to get right here, our major concern is, what is that ordered pair? So we know that it's 45 degrees. And this is the point on the terminal side of my little angle. And here's what we do. Every single time, we're going to drop an altitude. What's an altitude? Okay, so an altitude is a line that is perpendicular to the receiving line here. And, just comes down straight perpendicular. Okay, it is the shortest distance between the point and the line. Always perpendicular, okay? We do this again in calculus as well. So now what we've got then, if we're looking carefully at this triangle, is we have a distance x that I would travel in the x direction and the distance y to get to this point. So if I know this side length and this side length, then that's just my x and my y for my ordered pair. Does that make sense to you?
Yeah.
Okay. This is a 45, 45, 90 triangle, right?
Yeah.
Okay, so these leg lengths are the same, right?
Yeah.
Okay. And since it's a 45, 45, 90 triangle, we have some information that we just talked about, right? What are the leg lengths of a 45, 45, 90? 1, 1, radical 2, yeah? Okay.
So we already know that the hypotenuse is 1.
Very good. We already know our hypotenuse has a length of 1 unit to fit in my circle. Radical 2 is too big. All right, radical 2, you can do it on your calculator if you want. Radical 2 is 1.414. So it's slightly too big to fit. So we have to smush it down, which means we can divide to make it smaller. What should I divide by to turn this number into a 1? Divide by radical 2, yes. Now if I divide one side by radical 2, I got to do everything else as well.
And so that's radical 2, right?
Yes. So this turns into a 1 for our hypotenuse. And 1 over radical 2 is going to reduce or rationalize to radical 2 over 2 for both of these. All right. So what we did was we shrunk our triangle. Now it's the same size as this 45, 45, 90. So what is this side length here? Radical 2 over 2. Yes, 1 over radical 2. Same thing. And then how far do we go vertically? Radical 2 over 2. Does that make sense to you?
Yeah.
Okay. All right. So at pi over 4, the ordered pair is radical 2 over 2. And so then I want to go over here to this point, and we want to find this ordered pair at 3 pi over 4. Is that a different triangle? No, because when you think about creating that triangle, this angle is still 45 degrees. So once again, we still have the same triangle. It's just been flipped over. It was a bad drawing, but it is identical. Okay. So what is the ordered pair that's going to travel to this point then? Negative radical 2 over 2 and up radical 2 over 2. Very good. So now if I want to travel to 5 pi over 4, same size triangle, how do I travel there? Negative radical 2 over 2 and negative radical 2 over 2. So what are we only changing? The signs. And why do we change the signs? It's in a different quadrant. Yeah, so the numbers stay the same. All you have to do is change the signs based on the quadrant that it's in. So at 7 pi over 4, what is our ordered pair? Good. Positive radical 2 over 2, negative radical 2 over 2. So we go to the right, radical 2 over 2 units, and down radical 2 over 2 units. Okay? This is half of your unit circle. So why does this apply? So now we've got lots of triangles here that I haven't really drawn because I only drew the one. So it's called a reference triangle. I can ask you all kinds of questions like, what is the sine? Or I'm going to start cosine. So I'm going to ask you, let me use a different color. I'm going to use purple. Okay, I want to ask you, what is the cosine of pi over 4? Which we already answered, but we're going to use the unit circle this time. So our unit circle, here we are at pi over 4, so we get this triangle we've already drawn. I know that this length is radical 2 over 2, and the y length is radical 2 over 2, and my hypotenuse is 1. So what's the cosine ratio? Radical 2 over 2, adjacent over?
1.
Oh, what?
It's just radical.
It's just radical 2 over 2, which means it was just this x side length right there.
So
Cosine of our angle is always the x coordinate. Yes. All right? That's the beauty of having a hypotenuse of 1. All right? It doesn't matter when we take the ratio anymore. Okay? So you are right. Cosine of some angle theta is just the x coordinate, but that's only on our unit circle. So we do have to make sure that we're always on the unit circle when we notice that. So the x coordinate gives us the cosine value. Now, what is the sine according to pi over 4? Opposite over, yeah, so radical 2 over 2 over 1 again. So again, it's the y length here. So that gives us the sine. So the sine of some angle is the y coordinate. All right, so now here's the big money. How do we find the tangent of the pi over 4? It does just,
yeah.
so if we're looking at the triangle, it's opposite over adjacent, right?
Yeah.
So that's y over x. Very good. The y length divided by the x length. So in this case, they all happen to be just 1. Radical 2 over 2 divided by radical 2 over 2 is 1. But that was the y coordinate over the x coordinate. So if we want the tangent of some angle, it's the y coordinate over the x coordinate. And again, this is only in the unit circle, so we do need to be a little bit careful. But our ordered pairs all the way around give us the cosine and sine values. And if you know those two, we can get all of them. All right? The same is true if I asked you, hey, what's the cosine at pi over 2? It'd be 0. Yes, the cosine of pi over 2 is 0. What's the sine at pi over 2? 1. Okay. Very good. I think you got it. Now we're going to answer some questions. Imagine doing the whole thing in one day. So it's already long enough, right? Okay. All right, so we want to find the exact value of each trigonometric function. I don't necessarily want you to memorize the unit circle. There are really only 5 numbers you need to know because you already know how to draw angles so well. And if you know those 5 numbers, so today you learned 3 of the numbers. You learned the 0 and 1. Those aren't hard, are they? And radical 2 over 2. The only thing that changes are the signs, right? Okay. So what I do is just draw a little sketch of what we're looking at and think just about those numbers and those ordered pairs, okay? So we're going to draw a little sketch to help us out. We want to find the cosine of 315 degrees. I'm going to make a little sketch. This is about a quarter-sized circle here.
Are we just changing it to the high
Radians?
fraction?
You don't have to, because the degrees and radians have the same order pairs anyway. Oh, that's not pi. That's supposed to be 0. Sorry about that. Okay, so 0 radians, where's 180? Pi, yeah, so this is 180 degrees. Yeah, okay. Right here is 270, and then 45 more degrees would bring us to 315 degrees. So here is my angle in standard position. This is our 315 degree angle that I just drew. What we're going to do is, I want to know how big is this little angle?
180 minus. Wait.
Like the area? Oh.
45. It's 45. Yeah. So 315 plus 45 more gives me that 360, right? So I know that this is still my 45 degree angle. So what ordered pair is that landing at then?
7 or the order period.
Oh, it's
Negative radical 2 over 2, right? Everything you're getting today is over 4 or over 2. So yeah, so then we can say, well, what's the cosine ratio of 315 degrees? It's the x-coordinate, radical 2 over 2. Because cosine is the x-coordinate of our unit circle. All right, let's look at sine of 9 pi over 4. So I'm going to start again by drawing the angle. So we're going to draw our angle. First, where's pi? 180. So there's pi. And what do I need to divide pi into? 4 pieces. So first I'm going to divide it into 2. And divide it again. Whatever I do to the top, gotta do the bottom. How many wedges all the way around? 8 wedges all the way around. So I want to draw this angle. It starts here. The initial side is on the positive x-axis. And how many do we count? 9. So 1, 2, 3, 4, 5, 6, 7, 8. 1 more makes 9. So here is my angle. And it's an over 4. So what's the ordered pair? Radical 2 over 2, radical 2 over 2. So what's the sine ratio? The y-coordinate is radical 2 over 2. Okay. All right. So all we have to worry about then are positives or negatives, really. Okay. Tangent at 5 pi's over 4. So again, I'm going to make a little circle. I'm going to say, where's pi? 180. And what are we dividing pi into? 4 pieces. So 1, 2, 3, 4. Whatever